Well, hello everyone. My name is Lucas, and I'll be presenting HiSense, a solution for the detection of bacteria in aquaculture. Aquaculture is a multi-billion-dollar business, which has grown steadily in the last couple of years. However, aquacultural farms still lose millions of fish every year, resulting in production losses of around 5 billion euros. These losses are more prominent when the fish are still young smolt, growing in hatcheries, since they are highly vulnerable to bacterial infections due to their underdeveloped immune systems. These hatcheries are where they begin their lives before being transferred to nurseries and grow-out facilities, and most of them use recirculating aquaculture systems, or RAS. These rely on closed-loop water circuits and filtration systems. However, some bacteria can grow and bypass these filters, and because the water is continuously recirculated, bacteria can grow undetected for 2 or 3 days and spread very quickly from one tank to another. Therefore, if the outbreak is not detected rapidly, multiple tanks can become contaminated, and this is even before operators realize there is a problem. And thus, it results in losses surpassing 1 million euros. The most problematic of this bacteria is Vibrio, which kills around 1% of bacteria per day in a tank. So, if we know our enemy, what is preventing us from stopping them? The main problem is time. Microbiological culture tests take as long as bacteria need to spread throughout the entire system, those 2 to 3 days. So, there is a need for speed to prevent this. This need was validated by interviews we've had with aquacultural companies in Portugal, such as Necton and Ocean Fresco, that were kind enough to provide us their feedback and confirm this need. To solve this problem, we were inspired by nature's very own immune shield, antibodies. To capture the bacteria, we used cost-effective IgY antibodies obtained from the egg yolk of chicken eggs that were immunized against the desired bacteria. So, how do we detect them? The IgY antibodies are inserted and deposited onto an optical fiber where light is passing through. As the bacteria bind to the antibodies, the sensors feel the changes in the light caused by this attachment. As a result, bacteria binding creates a measurable optical signal. And this is where the HiSense system shines. The operator on the farm simply has to insert the disposable probe that has been prepared with the IgY antibodies into the interrogation platform and load the water sample from the tank. Within 1 hour, the system provides a clear result in a display panel, resulting and indicating the bacterial presence and concentration, which enables faster and more informed decisions on the field. We did the math on the market size, and we estimated that the global bacterial diagnostics market in aquaculture to be around $4.4 billion or euros in 2026. Specifically, bacterial diagnostics in RAS is estimated to be at $86 million, euros, with the European sector being worth 26 million euros, with a growth rate of 7.5%. We have also done some digging to figure out what the industry is currently offering, and while some technologies like PCR can rival the gold standard of microbiological cultures, they are still lab-based, and most importantly, they suffer from the same issue of taking several hours, if not days, to deliver results. Despite us being a new and still quality control pending technology, our key advantage is speed. By delivering on-farm results in 1 hour, HiSense enables farmers to make more informed decisions and prevent both economical and biological losses. For our business model, we will produce the sensor probes and interrogation platform, outsourcing almost all materials and processes, including the egg yolk for IgY production, from, for example, repurification technologies in Portugal. The sole exception to this will be the functionalization of the sensors with the antibodies. We'll then partner with a known distributor in the aquaculture industry, such as the AKVA Group, to reach a bigger market. Additionally, we plan to offer the interrogation platform in exchange for the acquisition of 52 or more sensor probes, similar to coffee machine plants. Our first goal on this long journey will be performing on-field validation tests for more bacteria and filing a patent request for the use of IgY on our sensors. Then we will begin test trials with partners that we have already shown interest in the technology, like the ones that gave us their feedback, followed by significant scale-up, both in production and sales. By 2041, we hope to have a functioning product and to expand into other businesses, like wastewater monitoring or public water monitoring. And then we will provide the data that we acquired from our experience in aquaculture as a data as a service business model. With that in mind, and according to our projection, we estimate our required funding to be 900,000 euros until we reach net profit, with the investors getting paid back 3 years after HiSense enters the market, around 2042. Of course, it's impossible to talk about HiSense without mentioning it's an amazing team. I'm Lucas, I'm a PhD student in engineering physics, and I'm here with Bernardo, a PhD student in nanoscience and nanotechnologies, and Simone, a postdoc researcher with PhD in biosensors for aquaculture. With our experience in biosensing and deep tech development programs, we will offer a solution that can help aquacultural farms take better preventive care of fish health. Earlier and more regular detection can save millions of young fish while they are still growing in their tanks. So help us make the fish happy until we eat them. Thank you.